Hi everyone, I hope you are doing well. So in this video we are going to discuss Leetcode problem of the day, and today's problem is least number of unique integers after k removals, and it is a medium level problem. The problem basically says that we have been given an array and an integer k. We have to find the least number of unique integers after removing exactly k elements. Now this problem can be easily solved with a very simple idea. So let me just take this as input and I'm just going to paste it here. Right. So let me sort all of these elements, or rather write their frequency. So 1 is present 2 times, 2 is present I guess 1 times, 3 is present 3 times, and 4 is present 1 times as well. Right. So if I ask you, there are 4 unique elements here, it is clearly apparent. And if I ask you to remove 3 elements, exactly 3 elements out of all of these elements, what should be the minimum number of unique elements left? So that basically means I want maximum of these elements to go to 0, right? I would want their frequency to be 0, only then that particular element will be removed from the array, right? So it basically reduces to a very simple problem. Let's say I have given you these values. I want you to make most of them 0, and you can only decrement them by a total of k, right? So you can either decrement this by 1, or decrement this by 1, or decrement this by 1, and or decrement this by 1. You can decrement by any amount, but the total decrement value should be equals to k, right? Or you can also consume less than k, but there is no sense. You would want to maximize the maximum value of k as you can, right? So basically these are the frequency of these elements. You want to remove all of these frequency by decrementing, and the maximum you can decrement is k. So you would always want, this is very simple and very apparent, that you would always want to decrement the smaller value first. If you decrement the smaller value, then there is a chance that you might be able to decrement more values, right? Or you might be able to make more of them equals to 0. If you directly start from the biggest value, it doesn't really make any sense. So you would want to decrement this one, then you would want to decrement this one, then you would want to decrement this one. So basically one will be utilized here, one will be utilized here, and since you only have one remaining, you will not be able to make this one 0. So in total, you were able to remove 2 elements from the total of 4 elements, and hence your remaining unique elements will be 2. Right. So this is how you can easily solve this problem. Just calculate the frequency of all the elements, and these are going to represent how many times they are present. Now you can sort this frequency by storing it in a vector or array. Once you sort this frequency, you will get all of the frequencies in an arranged order. Now you would always want the smaller frequencies to exhaust first because they are easier to remove. Now you can find out what are the maximum number of frequencies you can remove by using at most k decrementations, right? So this is all you had to do in this particular problem, and let me show you my code. So what I did was, I have created a frequency map f, right? Now I'm just going to traverse through my original array, and for each item you can clearly see I'm incrementing the frequency in my map. Now I've created a vector values, and I'm just going to go through the maps. Now these values are basically frequencies only. So I'm going to push back the I dot second into my values vector so that I have the frequency of all the elements. Now I'm going to sort this particular vector and initialize my answer with the value size. Now if I traverse through the whole values array, if my current value I is less than equals to k, that means I can make this current value equals to 0. I'm going to subtract I from k and then decrement the answer value. Otherwise I'm just going to break out of here and then finally return answer. So this would be the whole solution of this particular problem. You see, this problem was very simple, and let me just quickly submit this and show you that this particular code works and the solution is absolutely correct. So you see, this passes all the test cases and the solution is correct. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video. Don't forget to share thoughts in the comments, because your engagement with this video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.